Hello everyone, in this video all we're going to be doing is integrating our velocity formula so we can find our constant k from our position formula. Coming right up. Okay, so our question today is a particle's velocity is described by the function v of x equals to kt squared meters per second, where k is a constant and t is in seconds. The particle's position at t equals 0 seconds is x of 0 equals to minus 9 meters, and at t equals to 3 seconds is x equals to 9 meters. So what is the constant k with units? What we have to do in this question, what we have is the velocity equation, but we need to find our position equation so we can solve for with our values known here for our k constant. Right now we don't have any velocity values, so the easiest thing to do is to integrate this equation to get our position equation and then solve with our known values. Formula will actually equals to, so if I have an x of t equation, I get my x initial plus, and then you integrate from t2 to t1. Then I have my v equation t of t. So I integrate for those, but you have to add the initial position. So I'm just gonna add this here, x of 0 plus. So we can take the k out because it's a constant. So all the constants can just go outside of the integration. I'm going to write here how our integration equation goes, but basically all you do is if you have your t1 and t0, for example, and then you have any constant c, your t to the n, and then you have your tt, your integration of this will just be c, t, n plus 1 is your exponent, and then you divide by n plus 1 as well. So I have my x of t equals to my x0, and I'm going to take the k out like I mentioned before. So my exponent is 2, so what I have to do is get the bottom at 2 plus 1 is just 3, so multiply by 1 over 3, then t, and then again 2 plus 1 is 3. And that's by t1 and t0. All I have to do is plug in my values. So I have my 9, which is my x1, equals to my minus 9, plus my k again, and then let's solve for these values. I have 1 over 3, and then my t1 is 3 seconds, so 3 to the cube, right? And then I do this whole term again, but I have to subtract my t0 with my whole term. So I have 1 over 3, and then I have 0 cube. That will solve for my k because everything else is just numbers. So I have 9, we'll just take this 9 over here, so we have 18 equals, and then we know this term is just 0. So 3 cubed is 27, over 3 is 9, so equals to 9k. Well, we can divide this by 9, we can divide this by 9, so we get our k equals to 2. It's that simple. I hope that was easy and you were able to understand as I went a little bit fast on this. However, we have not accounted for the units. What I will do is use my velocity equation. Is much simpler than my position one. So I know that my velocity on one end is just my v, so that's meters per second. This is what I do to check for my units. My other side, well, I have my k, which I don't know what my units are yet. I have to figure that out here. And then I have t squared, so that's seconds squared, because it's just time. To solve for my k, I'm just gonna move this over here. So my k equals to, I have meters per second, which is what I had originally here, and then I move this over here, so I have 1/second square. So my units for K are actually meters per second cube. So my K equals to 2 meters per second cube. That's my constant. In this type of questions, all you're given is a formula or an equation of either a position, velocity, or acceleration, and then you're given values on, again, either position, velocity, or acceleration, but that are not for the same equation. You just have to either derive your equation or integrate it, and then you can find your constant that you are asked. If you have any questions on how to solve this or anything else, please just let me know.